hot seat. What are those people thinking? Nuclear hot seat. What have those boys been drinking? Nuclear hot seat. The corium is sinking. Our time to act is shrinking, but our activists are linking. Nuclear hot seat. It's the bomb.
Welcome to Nuclear Hotseat, the weekly international news magazine keeping you up to date on all things nuclear from a different perspective. My name is Libby Halevi. I am the producer and host, as well as a survivor of the nuclear accident at 3 Mile Island from just 1 mile away. So I know what can happen when those nuclear so-called experts get it wrong. This week, we revisit our interview with Dr. Timothy Mousseau on his groundbreaking On the Groundwork at Chernobyl and Fukushima on mutations that are showing up in a wide variety of species. And we catch up with Don Safer of the Tennessee Environmental Council and the Nuclear Matters Committee for the Sierra Club's Tennessee chapter on the Tennessee Valley Authority and why it really likes those small modular reactors. Plus, numbnuts of the week for outstanding nuclear boneheadedness, and more honest nuclear information than it looks like any U.S. governmental agency will ever be able to divulge ever again. Today is Tuesday, January 2nd, 2018, and here is the week's nuclear news from a different perspective. And I am sick, so this week's news is limited to
Nuclear hot seat, nuclear hot seat, nuclear hot seat, numbnuts of the week.
Donald Trump in charge of the nuclear launch codes.
Nuclear hot seat, numbnuts of the week.
We'll have this week's featured interviews in just a moment. But first, I try not to bug you too much about it, but it's true. Nuclear Hot Seat relies on your donations to help us keep going and growing and up and running and all those other cliches I've developed. It's because we want to bring you the verifiable nuclear news, no matter how awful it may be. Better to know than not know. And you know, any size donation is welcome. You can also sign up for a monthly sustaining donation. At $5 a month, think of it as what you would pay if we went and sat down for a cup of expensive coffee, and we gave a decent tip to the barista. That amount alone will go a great distance towards supporting some of the website and social media changes we've been wanting to make this year. These are meant to make Nuclear Hot Seat even more searchable and user-friendly and findable on the internet. So come on, help us out, even a little bit. Just go to nuclearhotseat.com, click on the big red donate button, and know that that automatically gets you my thanks for whatever you can do to help. Dr. Timothy Mousseau is an evolutionary biologist and has been a faculty member of the Department of Biological Sciences at the University of South Carolina since 1991. Beginning in 1999, Professor Mousseau and his collaborators have explored the ecological, genetic, and evolutionary consequences of low-dose radiation in populations of plants, animals, and people inhabiting the Chernobyl region of Ukraine and Belarus. More recently, he initiated a second research program in Fukushima, Japan. This interview was originally presented on Nuclear Hot Seat number 243 on February 16, 2016. Dr. Timothy Mousseau, welcome to Nuclear Hot Seat.
Thanks for having me.
Let's start out with giving people a sense of what your background and training has been.
I'm a biologist. I guess technically an evolutionary ecologist. I've been interested in the genetics of adaptation in insects and birds and plants for many years now. And I started off with fish, but moved into insects and then later into birds. Started working on things, climate change sort of questions early on. What are the genetics of how plants and animals adapt to changing environmental conditions? And just sort of slipped into different kinds of science as time went by.
What
drew you, or how did you slip into the subject of the impact of low-level radiation and the work that you did as a result?
Like so many things, it was completely by accident. In 1999, a former dean of mine had gotten a gift from an alumni of the university promoting exchange between Ukraine and our university, East-West exchange, as it were. And he sent over a pile of faculty and other folks to check out Ukraine to see what might be possible in terms of research and also business opportunities for folks in South Carolina. So I went over there, looked around, and got to see the site.
When you say the site, you're not talking about tourist sites, you're talking about Chernobyl.
I'm talking about Chernobyl. It was a miserable first visit, too. The airlines had lost my luggage in Paris, and nobody could find them. And so I was there with one T-shirt and a shirt and one pair of pants, and it was, September. It was freezing cold, and one of my colleagues loaned me an extra shirt so I didn't smell too bad. But anyway, we did the tour of the exclusion zone and got the full treatment, and it looked interesting, but at the time I didn't really see any opportunities. It wasn't until the next year that I was doing a sabbatical in Paris with Anders Mahler, another biologist, and we decided that, this might be a great opportunity to look at fundamental evolutionary processes in the face of this extra mutagen in the environment. People have studied how natural selection shapes organisms and populations and speciation, but nobody's ever really looked at how mutagenesis will influence this adaptive process over time. And so we saw it as a great opportunity to do some fundamental biology, and so we started going that year, and we haven't stopped going. So 2000 was the first year that we were working together on research projects in that Chernobyl exclusion zone area.
Did you begin the work with any expectations or any goals, or did you just go to look around and see what you could find?
Yeah, well, certainly, we are explorers, as it were, and discovery is really, a large part of what science is. Scientists are driven to explore new questions just because of their interest in discovery. And certainly that was a big part of our interest. But we did have some sneaking suspicion, some hope that there might be some signs of adaptation to this kind of unique environment. We actually had some thoughts that maybe the females, mothers in particular, might be doing some interesting things to their eggs to help the young survive in the face of this ionizing radiation. One of the areas of specialty I'd had at the time was so-called maternal effects, things that moms do to enhance offspring fitness. It's a whole class of adaptations that are really, really important across the plant and animal world. And so we were really hoping to discover some new kinds of adaptations related to how the organisms were handling the radiation. And we're still looking at that side of the question, but unfortunately, we really haven't found much evidence for adaptive response in an evolutionary sense.
What were some of your early findings from Chernobyl?
The first visit in 2000, we went out and found all of the barns, the old dairy farms that we could find in and out of the zone. We snuck inside the zone at the time. At the time, the exclusion zone wasn't really as high security as it is now, and so it was easy to sort of zip in and zip out with nobody ever catching you. And so we found a number of the old dairy farms that still had barn swallows in them, inside the zone, outside the zone, as well as in areas a fair distance away that were much cleaner, less radioactive, and started catching all the birds we could catch. And the first discovery was quite striking. Many of the birds living inside the exclusion zone or right on the border of the exclusion zone had patches of little white feathers on them. Nothing really striking, no three-headed monsters or anything like that. But these birds were extremely unusual. They were pale to begin with, but they also had these patches, what we've been calling partial albinos. There are other names for this phenomenon, but everybody sort of understands partial albinism when you say it. And this was much higher in the areas of high radiation. There are a few birds in the cleaner areas that show this, but very, very few relative to the hot areas. So that was sort of the first observation. We came back each year to these same farms to follow these same birds. And the beauty of barn swallows is that they'll actually come back to the same barn, the same nest, as long as they're alive once they start breeding. And so we put little bands on their legs so we could actually track their survival from one year to the next. We could see how many eggs they were laying and how well their babies were doing. And we could take a little blood from them so that we could look for genetic damage and antioxidant levels. And we figured out how to get a little sperm sample from the males so we could look at how well their reproductive materials performed. And all of this started to add up to an interesting story after a couple of years. First, we noticed that males in the more radioactive areas were showing sperm that was either deformed or not particularly active, not particularly good at doing its job. That was the first sort of clue that fertility might be an issue for these birds. Then we started to notice that many of the birds had other strange abnormalities, physical abnormalities, tumors on their heads, tumors on their feet and on their rear ends, and sometimes on their wings, just sort of abnormalities that you never see in a normal population. And so all of this kind of added up to the fact that these birds were not doing particularly well. They were living half as long as birds in clean areas. They were having fewer offspring. The male, as I said, the male fertility was lower. Recently, we've also shown that they have higher levels of cataracts in their eyes. It's just a plethora of negative consequences of the exposure to radiation. That was the beginning of all of this.
And you go back to Chernobyl still every year to do the updates on the bird population?
We do. We've been tracking the barn swallows every year. And, every year we try to add a little experiment to the pot so that we learn a little bit more about what might be going on. The fact that we've been doing it for 15 years straight, this will be the 16th year for these populations, gives us a lot of statistical power for the sorts of questions we're interested in. Some years we've been putting little dosimeters on the legs of these birds for the last 4 years. And so now we have a really good idea of how big a dose they're getting as they fly around, and that's never been documented before. We keep following these birds, but in 2003, 2004, we realized that barn swallows were great, but people, had broader interests than just barn swallows. Well, what we realized actually was that there was this growing interest in what was going on in the Chernobyl zone. We weren't just doing it to satisfy our own curiosity. At that point, we realized that other folks were interested in, and the questions that we were getting were, this is happening to the barn swallows. Is it happening to the other birds? What's happening to the insects? What's happening to the mammals? And so we started to branch out into a few other areas. We brought in other experts from other universities to collaborate with, to help us in some of the systems we had less experience with. And so now we've been working on the entire bird community. I guess 3-4 years ago, we added a group from Finland who are mammal specialists, small mammal specialists, and we've been trapping rodents in Chernobyl as well as in Fukushima, and learning an awful lot about other components of the ecosystem in the area.
Any results that you can report as yet?
One of the great things about working with, some of the best scientists, some of the most accomplished scientists from around the world on these projects is that, we're getting a lot done. We've published about 80 papers in the last 10, 11 years on Chernobyl and Fukushima, and folks can go to my website and get them all. But the latest results, we published a paper last week, actually. It came out. It was one of our first papers on the small mammals, the rodents of Chernobyl, where we document an increase in the rate of cataracts in the eyes of the females. We published a paper on the birds of Chernobyl 2 or 3 years ago, showing again that the cataracts in the eyes were at much higher levels in the more radioactive areas. Now we're seeing this also in the rodents. And so this provides substantial support for the hypothesis that, this is the radiation that's causing this. Folks tend to, if they can, they will throw out some objections to some of these ideas. They'll suggest that it's not due to the radiation, it's due to something else. And they'll have a long list. But clearly, the more results we have that run in parallel among different systems in Chernobyl, but also amongst the same systems in both Chernobyl and Fukushima, when we find the same kinds of results in both places, the only explanation that makes any sense is that it's the result of the radiation exposure. And so that's why we've invested so much into replicating most of our Chernobyl work in as much as we can in Fukushima as well over the last 5 years now.
When Fukushima happened, How long did it take before you and the other researchers were on site and taking samples?
Well, it was really a challenge. So as soon as the disaster happened, I realized that we just had to get there. We just had to get there to, not only because the science needed it, but we knew there was going to be a lot of questions related to the impacts. And the two disasters had, many similarities and many differences. And so it was really kind of important to get there as quickly as possible. The first thing I did was started calling around to the Japanese embassy, our State Department, our Department of Energy, and I couldn't get any answers from anybody about, whether or not we'd be able to do any research over there, whether it was going to be a problem to get into the zone. No one would answer any questions. And so by June of 2011, we decided that we couldn't wait any longer. We really needed to get there. And so I bought some tickets for Anders and I. Anders Mahler, my partner in research. He flew to Tokyo from Paris, and I flew from South Carolina. And we met there, rented a car, and just decided to dive into it. And we just drove up to Fukushima from there. It was the first time I'd actually had to drive on the left-hand side of the road. It was a bit of a challenge. But,
that's not the worst challenge you've been facing, Tim.
No, but it was certainly interesting driving on these tiny little Japanese roads on the wrong side of the road. But you just sort of follow the traffic and you do okay. But anyway, we got there. And we started driving around the area and realized that, oh my God, they had not fenced off most of the area. They'd fenced off the areas close to the reactor that had the highest levels of contamination, but there were vast parts of Namiya and Iidate, most of Iidate, all of Iidate, where, levels at that time, in July of 2011, were above 100 microsieverts per hour, which is, as you know, is extremely contaminated. And people were whizzing around in their cars. And anyway, it was good for us because it meant that we could access these areas without restrictions. And so we did manage to get quite a bit of work done in those 2 weeks. We did the first censuses of birds and insects that anybody had done, and they really haven't been replicated to any extent except by us every year. We've been there every year since then to repeat these surveys. And the basic findings are that the birds were hit quite hard the first year, and they have declined ever since. And the impacts have actually been increasing as far as the birds are concerned with each passing year.
When you say the impact, are you talking about the size of the population or mutations and changes that you have observed in existing populations?
So most of the work that we're doing in Japan with respect to the birds is looking at overall population abundances and biodiversity. And this we take as kind of a cumulative measure of how well these birds are doing. And the approach we've taken is to survey large numbers of locations. We actually have 400 sites spread across Fukushima prefecture. 300 of them are in very, medium to very hot, very contaminated areas, and then about 100 of them are in relatively low contamination areas. And so this gives us the ability to discern the impacts of radiation on population sizes and to look at how the populations are affected through time. The initial observation was that the birds and the butterflies were particularly impacted, and that the birds in particular have shown increased declines, increasingly smaller population sizes through time. And so last year we actually published 5 publications related to the abundance and diversity of the bird populations. The initial observation was that the birds and the butterflies were particularly impacted even that first year. With the birds, we've now since documented over a 5-year span that the negative impacts have been increasing on these birds, and that it really is a very similar pattern in some ways to what we've seen in Chernobyl over the years. We've published 5 papers directly related to the bird abundance and diversity in the last year or so on this question, and a couple more that were published earlier on. The birds and the butterflies, again, this coincidence kind of really sparked my imagination, because birds and butterflies are the only two groups of animals whereby the female is what we call the heterogametic sex. So, in humans, males are XY and females are XX. So males are heterogametic. They have gametes of two different types, and whereas females have two X chromosomes, so they're homogametic. In birds and butterflies, it's reversed. It's the female that's heterogametic. And the relevance is that what we know from genetic theory is that mutations that occur on the sex chromosomes can be expressed immediately without, having to have a second copy of that mutation on the matching chromosome. And most genes, because we have two copies of most genes or more, if there's a problem with one copy, because of the redundancy, because we have two copies, the other one will do the job, and you don't even notice the mutation most of the time. But when it occurs on the sex chromosomes, it can be expressed right away, and that can have an impact on fitness. And when it's a male that's being zapped with mutations, it often doesn't matter, because most species are polygynous and females will mate multiply. And so if there's a dud male out there, it doesn't show up in terms of population growth rates. But when the female is expressing these mutations, it directly affects egg production. And when egg production is affected, then population growth rates are also affected, and that can happen immediately. And so I had this notion that perhaps birds and butterflies were showing this high sensitivity, at least as measured by population growth rates, because of that shared genetic system. And we've just since finished an experiment to test this idea by looking at the moths in the area. Turns out moths are all one other group of animals that have that same kind of sex determining system. So that's the sort of question that really turns me on.
Clearly. Are there other species that you are currently studying in Fukushima besides the birds, butterflies, and moths?
Yeah, we're also looking at the rodents. We've been catching mice all over the place. We've caught several hundred of them now. We're in the process of examining their eyes for cataracts, their internal organs for tumors, and other developmental abnormalities and color changes. We have some preliminary data that suggests that the rates of tumors, particularly on the liver and perhaps the bladder, are much higher. This hasn't been published, so this is just a hint. Until it's published, it's not real, of course, but for the sake of entertainment value, it's worth sharing.
Have you done any studies on fish or other forms of sea life?
I would love to do work on fish. My first love as a biologist was really with fish. It's much harder to do work on fish. We're starting to do a little bit of surveillance with the fish in coming to the U.S., but that, again, is really just a sideline. It requires much greater resource availability to be able to work with marine systems, and there just hasn't been that kind of investment for research at this point. But we are looking at the microbial communities, the bacterial communities, and fungal communities. We're looking at the trees, looking at tree growth rates, again, replicating a number of the sorts of studies that we did in Chernobyl to look at ecosystem-level effects, not just population-level things.
What sort of results are you finding at Fukushima that suggest that the mutations and the changes will follow the same pathway that's been followed more than 30 years after Chernobyl?
It's really too early to say for sure that they're identical. There are a lot of reasons why they should be different. But to begin with, the first observation we made from the very first year of our study was that there are a number of species that are common to both Chernobyl and Fukushima in the bird community. I think we had 14 or 15 species of birds that were the same, and they showed similar patterns of effect due to radiation. So that was sort of the first clue. Again, the fact that the birds show this strong dose-dependent decline in population sizes. We published a paper in December where we actually took the 7,000 birds that we've counted over the last few years, and in collaboration with a group in France at the IRSN, they actually calculated a dose to each and every individual bird. And this is what the health physicists like to see, of course. They like to see that radiation exposure in terms of a dose, because doses can be different than just the exposures. And so we did this in collaboration and basically found the same pattern of declines with dose that we've seen in Chernobyl. And so this, again, is that level of convergence is really striking and really speaks to a likely common mechanism underlying the two effects, namely ionizing radiation. So we're pretty confident that level. We've also been looking at brain size, in the rodents, and we're seeing evidence. It's not published yet, but it will be soon, I hope. Again, parallels in the two places with respect to rodent development. And we're just finishing the analysis of tree growth before and after the disaster. Again, in Chernobyl, we found very striking impacts on the pine trees of the area. We're looking at 4 species of trees in Fukushima. They've all been measured. It's just time to analyze the data and actually write up the paper.
In terms of the kind of radiation that is hitting in these two areas, are they the same, or is there some difference in the radioactive isotopes?
In Chernobyl, because there was a nuclear fire burning, along with a regular fire, the graphite rods were burning, fission was undergoing at the time. It actually volatilized a very wide range of different isotopes, in addition to the usual characters, the radioactive noble gases. There was cesium released in both places, but the strontium was not volatilized in Fukushima. It wasn't hot enough during the meltdown to volatilize the strontium. At least that's the story we're told. Whereas in Chernobyl, enormous quantities of strontium were released across the environment. It's been well documented, well measured. Strontium is everywhere. The strontium-90 has about the same half-life as cesium-137. It's 29 versus 30 years. And so it's around still in great quantities. It's hard to measure because it's a pure beta emitter, so a standard gamma dosimeter does not measure it very accurately, although a Geiger counter can pick it up if it's close to it. Of course, at Chernobyl, there was lots of plutonium. This spent fuel was actually volatilized as well, in the unspent fuel, and released in this sort of cataclysmic event. This fire that was burning was sort of like a volcano spewing radioisotopes into the atmosphere, injecting it into the atmosphere. And so they were transported far and wide, hundreds of miles and longer. Whereas in Fukushima, on the terrestrial side of the event, really was limited to the noble gases, radioactive iodine early on, and the cesium-134 and cesium-137. And so now, 4 or 5 years later, that's what we see on the terrestrial side. We see the cesium is still there, cesium-134 and cesium-137. There's very little evidence, as far as we can tell, for strontium. We see the occasional blip of some of the other isotopes that are common, silver isotopes, for instance. But on the terrestrial side, again, on the land, it's really just that one isotope. And also the other issue is that the amount of land that was contaminated to a high level was considerably less than what happened in Chernobyl, where vast areas, hundreds of thousands of square kilometers were contaminated. So it's a completely different event in terms of the terrestrial impacts. The marine side now, that's another issue. The inputs to the marine system were vast, extremely large, probably, again, on the order of the Chernobyl event, and certainly a much wider array of isotopes have been put into the ocean, certainly lots and lots of strontium as well as cesium, and there's certainly indications of some plutonium and other isotopes making it into the marine system as well. So again, that's a completely different event, and that's ongoing, and we know almost nothing about it. So that's the big problem right now.
In your research on either site, what has been your biggest surprise?
There's been many. The biggest surprise and the biggest disappointment has been that there hasn't been fundamentally much greater interest on the part of granting agencies and regulatory agencies, and we sort of could understand why interest in the Chernobyl disaster was waning onto the 2000s as we were getting involved in it. Everyone thought that this kind of disaster could never happen again, that Chernobyl was a unique event, unique to the former Soviet Union in many ways, unique to that particular reactor design. It could never happen in the modern world, in the Western world. And then Fukushima happens, and of course, everybody realizes, oh my God, it can happen here. If it can happen in Japan, it can happen anywhere. And so we really kind of expected that there would be much broader interest in supporting a large multinational effort to conduct as much research as possible and to take advantage of this opportunity to learn so that we might know much better how to deal with these kinds of accidents, small and large, in the future. And so, yeah, big disappointment, big surprise that there hasn't been a much broader array of interest. Now, certainly there's been lots of public interest, lots of interest by the media, just not any evidence of investment by government agencies or other folks that should be investing in this kind of activity.
Given that you have such a tin ear turned to you by government agencies, where have you gotten your funding to be able to do this work?
Like a lot of people, we've done anything and everything we can to support our hobbies. And, for scientists, of course, research is everything. It's our whole life. And so we invest whatever it takes to do what we think is important to do. And certainly that's no different than most other avocations, I think. And so I was just very, very fortunate that my university was very supportive of what we were doing and has helped us out considerably over the last 15 years. We've had a number of grants from, the National Science Foundation, from the National Geographic Foundation, from the National Institutes of Health, as well as several small philanthropies that have promoted our research. But of course, as I like to say, the biggest funding source really has been personal prostitution.
Oh, please clarify, please.
Yeah. Basically, working at other unrelated activities to support my research habit, and that has really been the primary source of our funding.
What, if any, pushback have you gotten from the officials out there, be it government or organizations or the nuclear industry? Has there been any concerted attempt to contradict your work or put roadblocks up to it?
I don't think there's been any well-orchestrated conspiracy by any group to put up roadblocks. There hasn't been much help from a number of these groups. I guess it's kind of a passive-aggressive thing. The lack of support in its own way is a roadblock, of course. Scientists are craftsmen, and, like a plumber, if you don't pay the plumber, he's not going to come do the work, and scientists are essentially craftsmen, and without funding resources, most scientists are not able to conduct research. And so most of the roadblocks have been this kind of passive-aggressive kind of thing. But for the most part, the only really vocal criticisms we've had to face have been surprisingly from some of the more extreme anti-nuclear groups that have gone a little bit hypercritical at times. That's been kind of a surprise as well.
Has there been any outreach to the United Nations to do a more coordinated international job of monitoring the impact in these two areas?
Again, depending on who you speak to, if you talk to the folks at the International Atomic Energy Agency, which of course is the agency at the UN in charge of regulating or making recommendations concerning regulations and promoting the peaceful use of the atom. And
leave it alone! That's the peaceful use of the atom! Leave it in the ground and leave it alone. But be that as it may, please continue.
Yeah. So there have been, I think they have invested in reviewing the literature as it is and as such as they believe it to be, and have advisors here and there to make recommendations on how best to clean up and reduce the potential health risks to the local population. But I don't think there's been any major investment in any kind of research initiative. The Japanese, I think, have started a kind of research initiative, again, through the government agencies that are there, but nothing that would be open or available to independent scientists at academic institutions. So it's been rather limited.
I have to ask, with you having been at Chernobyl so many times and having been at Fukushima only months after the disaster happened, being up close and personal with two of the worst, most contaminated nuclear hotspots on the planet, what have you done and what do you do to protect your health?
Yeah, that question has become increasingly important. Most of the radiation that we experience comes in the form of gamma radiation, and as such, like X-rays, there's really no way to protect yourself from it other than to not be there. And so to get the work done, you have no choice but to subject yourself to some extra gamma radiation. We minimize our exposure to the other forms of radiation, the beta and alpha emitters, by trying not to eat the local food, trying not to drink water, trying to keep the dirt out from under our fingernails and not breathe the dust. But, like journalists going to war zones, there's really no way to avoid the bullets when you're actually there. And so you just have to, again, minimize the potential risk as best you can. Try to be careful. But if you want to do this research, if you think this needs to be done, then there's no other way to do it than to be there.
And how is your health at this point? Are you holding together?
Yeah, good question. Unfortunately, the ravages of time are my main issue. None of us are getting any younger, unfortunately. And this brings me to the next point, which is that because there's been this lack of investment, the lack of resources, the other thing that you can't do without resources is train new students, bring new students and postdocs, young people. To get them involved, you've got to provide incentives. You've got to be able to cover their expenses. And we're not training the young people that we really need to train to continue this work into the future.
Where is your work going now? What's next, and what do you project for yourself and the researchers with whom you do work in the near and the far future?
We think it's critically important that we continue to monitor these populations for probably several decades. We jumped into Chernobyl 15 years after the event, and we missed so much of what happened during those first 15 years. That was another reason we felt compelled to get there as soon as we could, again, to fill in some of those gaps that really weren't documented following the Chernobyl disaster. But it's very clear that this is a dynamic process. It's an ongoing process that takes many years to reach any kind of equilibrium, if it does at all. Again, as evolutionary biologists, as population geneticists, we suspect that there will be some kind of equilibrium reached between immigration of animals and plants from adjacent areas that are not contaminated and those that are experiencing this mutagenesis as a result of the radiation, and that the dynamics will be different in different places depending on the size of the areas that are affected and other environmental factors. But back up 10 years ago, when we started doing work in this area, nobody thought that there were any consequences for the populations living in Chernobyl. The dogma at the time was that, as published in the Chernobyl Forum reports of 2005-2006, the dogma was that the animals and plants were actually thriving in the zone because there was a fence around it, people weren't hunting them, and the radiation was low-dose radiation, which probably didn't really matter because animals die before the effects of radiation would hurt them. And what we've learned in the last 10 years is that is absolutely false, that the consequences of the radiation exposure, especially in the areas of high radiation, it's most evident in these areas of higher radiation, but it's happening all the way down to very low-dose rate areas. They're significant, and they're having very large impacts on some of the populations. The other thing we learned that nobody really knew anything about was that there's tremendous variability among different species, even among individuals of the same species, and how they respond, how they're affected by this radiation. And again, we're just starting now to get a much better idea of what that might be related to. We published a paper earlier this week that documents a really interesting property of these radiation-affected systems. There's very clearly a trade-off between the use of antioxidants and its consequences for oxidative stress and impacts on the success or disease in these organisms, that this balance between antioxidants and oxidative stress is what's really driving much of the individual and population level responses that we're seeing.
For those of us interested in supplementation, are you saying high levels of antioxidants show that there's an ability to resist the radiation?
That's what it looks like when we review all of the literature related to these two factors, antioxidants and oxidative stress. It does look like there is this trade-off between the two, and one prediction from that might be that, yes, antioxidant supplementation might be beneficial in terms of addressing the issues. And that's not new, really. You know, people have talked about that a lot over the years. And it's not just radiation that causes oxidative stress. Even just exercise, causes oxidative stress. So antioxidants are good for you. But it seems that antioxidants are particularly good for you when you're suffering from ionizing radiation exposure. And so we're starting to get a handle on these kinds of underlying mechanisms associated with sensitivity. And so it's really critical that this kind of work continue into the future, that there be more experimental studies, studies that run parallel in the lab and the field. Again, using the field observations to direct the sorts of experiments that are needed to be done in laboratory conditions, but using what we see in nature to help us understand better what's actually going on. So there's that kind of thing that really needs to be done, and we're hoping to be able to move in that direction a little bit more. We're starting to do genomics, whole genome scans of various organisms, and this we're hoping will provide, again, fundamental clues as to how the genome is influenced and how that results in disease of various sorts under conditions of ionizing radiation. So all of those kinds of things. You know, the downside is that most of those kinds of that kind of work is very expensive, so there has to be some support.
If you had unlimited funding and could do any study, I mean, let's put it out there, let's dream the big dream. You could do any studies you chose or direct others to do any studies you chose. Where would you want the attention to be put?
The relationships between, again, survival, disease expression, the physiological mechanisms underlying variation in the expression of these characters, and the genetic mechanisms associated with it. There's just a whole suite of genomic tools now that are available to help us better understand how individuals respond to these different kinds of changes or influences. And that's where we would be putting the funding at this point. Again, combining field-based research, observational research and experimental research to help direct the finer scaled studies that are needed to understand the underlying mechanisms associated with the risks of ionizing radiation.
I guess the big question behind all of this is supposition now. How would you say that the work you're doing extrapolates to human beings and human survival?
The big question. So, clearly there's some relationship. Humans are just animals too. Humans have the same fundamental genetic systems, the same fundamental physiological systems that react in very similar ways to what most other animals, how they react as well. And so what we're finding in the mice in particular, the studies we're doing on the rodents are particularly relevant for humans. We use mice and rats in medical research to a very large extent because of their similarities to humans. In Fukushima, there are opportunities to do really important or potentially important research because of the abundance there of the wild pigs. There's wild boars and pig hybrids that are scattered throughout the area that could be, again, studied for the direct benefit of humans in the region. They also have monkeys living in this area. They have these Japanese macaques that are scattered throughout the zone in fairly large numbers. And to my knowledge, there's really minimal effort to make use of these systems to better understand the impacts in a way that would be directly related to consequences for humans. The main difference with the humans, though, is that they are luckily mostly evacuated from the areas of highest contamination. The downside is that even if humans are affected to the same extent that we see with the animals, and I suspect they are in one way or another, but because of the lifespan issues, the fact that humans live much longer, it takes much longer for these consequences to be expressed, and by that time it'll be too late. And so the studies that we're doing on plants and animals and microbes potentially serve as a valuable warning bell of potential hazards to the humans in the area, we hope.
What can the listeners of Nuclear Hot Seat do to help support this critical research that you are doing?
The usual sort of things. If you think that this kind of research is important, even though it's in Japan and Chernobyl, but if you think it has relevance for your life here in the U.S., let your elected representatives know. And, this is, of course, the way things move forward in this country. And, of course, if you happen to have an interest in directly sponsoring research, that's always a possibility, too. There are mechanisms to provide personal funding for this kind of effort through the university foundations, for instance. It's tax deductible, even.
I can see a Kickstarter campaign on the horizon.
People keep suggesting this to me, and I've avoided it so far. But, yeah, again, I think every little bit helps, and so I think we may consider that option in the future.
Well, if you do, Nuclear Hot Seat stands ready to help you get the word out.
All right. I appreciate that.
Dr. Timothy Mousseau, thank you so much for being so informative, for doing the work that you're doing, and for being my guest this week on Nuclear Hot Seat.
Pleasure, Levy. Thanks for inviting me.
Dr. Timothy Mousseau. We will have a link to his website and the article he mentioned up on our website, nuclearhotseat.com, under this episode, number 292. For the episode I did covering last December's Nuclear Waste Strategy Summit in Chicago, which was hosted by NEIS, I interviewed more people than I had room for on the show. One of them was Don Safer. How's that for a name for an anti-nuclear activist? Safer. Don starts out by introducing himself, as was the format for that program.
My name is Donnie Safer. I'm in Nashville, Tennessee. I work with the Tennessee Environmental Council and also the state chapter of the Sierra Club. And I also work with the National Group of Volunteers, Sierra Club volunteers, that we call the Nuclear Free Corps Team. First off, I think the 100% agreement is the first place to start is to stop making this waste. The beginning of dealing with this waste for the long haul, which was the focus of the conference, was to responsibly deal with the high-level waste. So stop making it is the first thing. And the second thing that I think virtually everybody agrees on is that current treatment by the governments of both the United States and Canada is inadequate and potentially very dangerous, and those issues need to be addressed. They're highly technical issues, and there was not total agreement coming out of the conference or going into it in the details of how you deal with it, but there was pretty much 100% agreement that we need to do and have to do a whole lot better than we're doing now with this material, and have to come up with a logical, reasonable, scientifically based strategy to make sure that it's isolated from the environment for basically forever.
In the work that you do, you work on issues with the Tennessee Valley Authority. What has been your focus to date?
Kind of multi-pronged. The overarching focus is to encourage TVA to be true to its founding vision and become a force for transformation of the Tennessee Valley to a new energy paradigm based on renewable energy, energy efficiency, and not using destructive, dirty fuels like coal, natural gas, and uranium, nuclear fuel, for electricity. So that's the overarching. The individual has been to get them to, at this point, the major focus is to get them to stop their, they call it Small Modular Reactor program. It's really more of a multiple modular reactor program because when you put all those together, there really will be nothing small about the complex. And TVA wants to be among the very first in the country to build these things, and they can't possibly be operational, even the industry says, until 2025 or so. And as we know about the nuclear industry, their time frames are always much longer than they think at the beginning, as is the money. So that's the current focus. The past focus has been on the Bellefonte nuclear plant, which is in northern Alabama, to stop it, and then also to stop the Watts Bar Unit 2, which has been recently commissioned and has been operating in fits and starts. They've had 2 fires since they've fired it up. neither of them, according to TVA, resulted in the release of radiation. One was in the switch yard, a transformer, so that wouldn't have had anything to do with radioactivity. So stopping Watts Bar, which we did not succeed in, stopping Bellefonte, which we did sort of, but we call that the zombie reactor, reason being that we kill it and then it comes back, and this has happened multiple times. And then the Browns Ferry reactors currently, TVA, these are 3 GE Mark I reactors, just like the ones at Fukushima, and TVA has had a lot of trouble with those historically, and there's been a lot of issues that the Nuclear Regulatory has found in terms of safety-related issues and safety culture. And TVA, despite acknowledging that it doesn't need more power at this point, is in the process of an extended power uprate, which involves running the reactors, basically stepping on the gas more, and if you were in a car, and running them just harder to get 14% more electricity than they're currently getting out of them. And they've been operating for over 40 years, the ones that weren't closed down for different, the big candle fire and other things. With the Tennessee Valley Authority, they have 7 operating reactors now, so there's a lot to keep up with in terms of their nuclear, and then their aspirations for these multiple modular reactors near Oak Ridge.
If people want to know more about the work that you are doing and perhaps join with you, where's a good place for them to go to get more information?
They can go to the Tennessee Environmental Council website, tectn.org. That's the best place to get me. To find out more about what's going on in the Southeast, there's a website, mothersagainst-tennessee-river-radiation.org, and these are some allies I work with, and the Southern Alliance for Clean Energy.
That was supposed to be the end of our brief snippet. But as so often happens when I speak with an interesting guest, our post-interview talk provided some compelling information. We started by chatting about the areas of the country most impacted by the threat of small modular reactors, or SMRs, and the activists working on them, but unexpectedly arrived at some startling revelations about Oak Ridge and the possible reasons behind its push for SMRs.
Sarah Barzak of Southern Alliance for Clean Energy and Chuck Johnson of Physicians for Social Responsibility in Oregon. And then Beatrice Brailsford right in Idaho, because that's the other place that modular reactors are being talked about being built. She's on the ground there at Idaho Falls, so monitors that pretty closely. Chuck monitors the NuScale application for certification, design certification, which is supposed to be submitted soon. And, of course, Ed Lyman is also quite good technically. It may be more timely to go into that once NuScale does submit their design application, and my understanding is that Ed, once that is in, is going to be going over that to review it for safety and whether it makes sense at all. So many times these things don't, and Ed is quite good at doing that analysis. Basically, TVA has submitted an early site permit application for its site at Oak Ridge, but they don't have a reactor they could build there because nothing's been certified. But that process is ongoing. That application hasn't been accepted by the NRC, but TVA is answering the questions that the NRC has come up with to begin the actual process of reviewing it, the NRC process of reviewing it. So there are 2 applications pending that I think if and when NRC accepts the TVA application, the clock will start ticking on that, and Lou Zeller is planning to do an intervention on that early site permit application. You know Lou, I'm assuming.
Yes, Lou's been on the show, and we've met in person, actually, at a couple of conferences.
Okay. So he's planning to go over that application and to do an official intervention within the deadline, which it's not started counting yet. And then the Utah Associated Municipal Power Systems, which is UAMPS, is the other place in Idaho Falls where these multiple modular reactors are being proposed, and it's also right at a DOE facility, and that's not an accident. DOE is really pushing to get these things done, even though the economics are just miserable. I think it's a desperation attempt to keep something going in the nuclear pipeline, and there's so many flaws that Diane DeRigo calls them magical modular reactors.
Magical. That's another one I was just writing down. Small, multiple modular reactors.
throw the magical in there and we could make it SM3R, with a cubed, because the claims they're making, the industry is making, are just, they're magical. It's magical thinking,
The whole industry makes absolutely no logical sense on any level that I can come up with. My catchphrase on the show has been the cute little modular reactors, because they're small and they're modular. They're like Legos. Put them all together with each other. But this is the first time I'm hearing any kind of clarity about, when they say modular, they're talking about putting multiples in a single space.
Yes, and in the application for the early site permit, TVA is saying that the total footprint for the facility would be virtually the same as the Clinch River breeder reactor, the fast breeder reactor that was proposed decades ago and, of course, got canceled. But that was no small reactor, as far as I know. And if you look at the pictures of what NuScale is planning, 12 of these things in the same pool with its own spent fuel or highly irradiated used fuel, all in the same pool that is underground. And the NRC, we're understanding, has made the decision that NuScale doesn't have to consider the possibilities and implications of multiple reactor problems, like already happened at Fukushima. So they're just saying, well, if something goes wrong with one, we'll deal with that, and that's the only thing that's our design basis accident. And it's kind of like, well, when something starts going wrong with one, it could easily start going wrong with another one, and these things are all next to each other, underwater.
They are out of their frickin' minds unless they know something about how to neutralize radiation and its impact on people and the environment. So they have a secret way of surviving this that the rest of us do not, and I do not believe that is the case. They're writing their own doom as well and thinking they can get away with it just because they're making whole bunches of money.
Yeah, building off of that thought, one of the reasons that the DOE wants these things so bad is they are purporting, they're pushing them as dedicated sources of electricity for DOE facilities that will not necessarily be hooked up to the grid. And they are actually talking about burying the transmission line from the Oak Ridge reactors, the Clinch River reactors, to an Oak Ridge substation so that they have a secure source of electricity that's just for the Oak Ridge Defense Facility and labs, that if the rest of us around the TVA land are in the dark and in the cold or the heat, whatever it may be, they're still going to have electricity at Oak Ridge to continue to make bombs or keep their computers running or whatever it is they feel like they have to do with the rest of us without any electricity. But that's one of the reasons they are saying they want these reactors. So that would be kind of the first step. If you have a dedicated power source and it's secure, then maybe they'll start putting whole facilities underground, like in the Cold War days when there was a government space near Thurmont, Maryland for the U.S. government to move to underground. And in Nashville, I used to live right near the one that the state government was going to retreat to that was under a mountain or a hill here outside of Nashville. So whether that's the plan and they're planning to build these things big enough for their families and who gets in and all that, I don't know. That becomes science fiction, but it's not science fiction that they do want to bury the transmission line to Oak Ridge, and they're talking about a dedicated source of power that they claim can virtually run itself because it can't possibly melt down.
And if you believe that, they've got some land in Fukushima Prefecture they'd like to sell you.
Yeah.
Unbelievable.
Don Safer of the Tennessee Environmental Council and chair of the Nuclear Matters Committee for the Sierra Club's Tennessee chapter. This is Libby Halevi of Heartistry Communications, the heart of the art of communicating, reminding you that nuclear is a women's issue, and a men's issue, and a children's issue. And now that we've all had our nuclear wake-up call, do not go back to sleep, because we are all in the nuclear hot seat.
Nuclear hot seat. What have those boys been drinking? Nuclear hot seat. The corium is sinking. Our time to act is shrinking, but our activists are linking. Nuclear hot seat. It's the bomb.